Welcome to today's maths class. Today we'll be looking at mass versus weight. Let's look at the objectives. So first, define mass separate from weight. Secondly, analyze terms mass and weight. Third, use Venn diagram to highlight differences and similarities. Last but not least, calculate weight. So let's get right into it. Mass. Mass is the amount of matter an object has. How to measure mass? We often use a triple balance beam to measure mass. And here's a diagram for a triple balance beam. Unit of measure: grams, kilograms. Let's continue. Mass is constant, meaning it doesn't change. For example, the weight of an object changes according to gravity, but its mass remains the same. A brick would be weightless in space, even though it still has the same mass as on Earth. Alright, so please note, mass doesn't change. Let's look at weight. Weight is the measurement of the pull of gravity on an object. How do we measure weight? Weight is measured on a scale, and here's a diagram of a scale. Unit of measure: Newton. Commonly used unit of measure: kilograms. So I know that some of you may be seeing Newton for the first time. However, kilograms is generally used so that confusion doesn't occur. Alright, let's continue. Weight changes according to gravity. Weight is a force which is measured in newtons. On the Earth's surface, gravity makes a 1 kilogram mass exert about 9.8 newtons of force. Therefore, mass times gravity equals weight. Alright. So, first activity. Fill in the blanks. So we have mass, weight, newtons, kilograms, gravity. So we have 5 blank spaces. So pause the video and have a go at it. Alright? Mass versus weight. Mass is a measurement of the amount of matter something contains, while weight is a measurement of the pull of gravity on an object. Mass is measured by using a balance comparing a known amount of matter to an unknown amount of matter. Weight is measured on a scale. The mass of an object doesn't change when an object's location changes. Weight, on the other hand, does change with location. So here's a Venn diagram showing similarities and differences. So differences: weight can change based on where you are in the universe. Mass stays the same unless something is added or taken away. Similarities: they both indicate how something is. They are both measured in kg. They are both equally valued on Earth. Alright. So here's your assessment. Keep calm, don't be anxious. Math is delicious. Alright, so over here we have a little worksheet that you'll be using the formula for weight to do some calculations. So the main focus: how much would you weigh on other planets? So my mass is dash kg. So you put your mass here, and then for Earth its gravitational pull is 10. So you put your mass here. Then you use a formula which is multiplying gravitational pull times mass. Then you get your weight. Alright? So for example, say your mass is 120 kg. You have 120 here. And your weight would then calculate to be 120 times 10. Which gives you 1200 newtons. Alright? Very simple. And then you have questions down here. What happens to your mass as you move from one planet to another? On which planet did you weigh the most? On which planet did you weigh the least? On which planet was your weight most similar to your weight on Earth? Alright? Very simple. So remember to like, share, and subscribe. And I do hope that I will see you again.